Hey, let me share with you some simple trigonometric function graphing. We're going to graph two functions and they're both related to each other. One is the reciprocal of the other. They're very simple. The first one is y equals sine x, where x is in radian measure, and its reciprocal y equals cosec x, and again the x is in radian measure. We're going to draw it, and it's going to have an amplitude. They're both going to have a period, and a period is when the curve repeats itself over and over again. So we're going to work that out, and then we're going to sketch them up and see what they look like. So what's the first thing we want to do? Well, the first thing is let's check out if we can work out what the amplitude is. By looking at them, sine x, for example, it's essentially saying y equals 1 sine x, so that 1 would be the amplitude, and that's going to be absolute value. And the amplitude is between the middle horizontal x-axis and the maximum, or the middle and the minimum. So whichever way you want to go, that's the amplitude. Now for here we got 1 sine x, the amplitude is going to equal 1. So it's going to start from 0 and go up to 1, there's our 1, and also down to -1 for the minimum. So that's the amplitude, that's the range in there. And the same thing with cosec, it's up and down by 1. So they're both going to be marked out there. Next thing is to work out their periods. Now the period, as I said, is the part that repeats itself over and over. And P, the period, equals 2 pi on B, where B is the number or the coefficient in front of the X, which is in radian measure. So right in front of there is the B. We don't have a number, so it's just a 1. So B is going to equal 1. So let's just kind of work that out. So the period equals 2 pi, and of course the B is 1. So the number in there is 1, the number there is 1. So both of them have essentially a period of 2 pi. So what's the next step? Well, the next step is to mark out that period. So let's write down the horizontal x-axis and break it up. So the first thing is we have a period of what? 2 pi. So 2 pi would be here in radian measure. And of course 0 is at the crosshairs right over here. And it's a sine curve we're starting off for. So it starts at 0 because sine of 0 is 0. So we know that. It's going to repeat itself. So if we're going to go from 0 to 2 pi along that domain, let's break it up into quarters. So 1/4 of 2 pi will be half of 2 pi would be, and 3/4 of 2 pi is, okay, that's where we're going to break it up. And now we can simply put in that curve. So in order for us to put that in, let's mark it out. The curve starts over here. So that's the first what we'll call right there at 0, 0. Then it's going to cut again at pi because sine of pi is 0. It's going to cut through there. And we know it's going to cut through 2 pi also. In fact, that's where it's going to finish. So that's going to be one period. It's going to start at this place and finish exactly the same place right there. So that's the one period, the whole period, which is 2 pi. Now it's going to go up to a maximum of its amplitude, which is 1, isn't it? So it's going to come up to here. Its maximum will be pi on 2, 1, which would be approximately there. And its minimum will dive down here, would be about here, which would be -1. Yeah, just about there. So 3 pi on 2, -1, which is approximately right there. So the curve's going to do this kind of a thing like that. So we can kind of mark that curve in. So let me just mark it in with something more solid than just a drawing. So we're going to have the curve doing this kind of thing. Yeah, do that. So that's rough. Kind of rough about there. Okay, there's our sine curve right over there. It goes up to a maximum of pi on 2 and 1 through pi, 3 pi on 2, -1, and of course finishes at 2 pi. That's a full period. So this cycle will repeat itself over and over again. So we've got the sine curve there. Now, what else do we need now? Well, we need to draw the next curve, which is the cosec. And cosec is the reciprocal function. And you might recall, you probably know this already, that cosec x equals 1 over sine x. One is the reciprocal of the other. So that means that every time we get sine x cutting the x-axis, in other words, the x-intercepts, in other words, where sine equals 0, that's where we're going to get what? If sine equals 0 at certain places, like here, for example, sine pi is 0, meaning cosec, or the reciprocal, will be what? Undefined. So that's a place we know is going to be an asymptote. So where are the asymptotes? Well, wherever, as I said earlier, sine is 0. Well, sine is 0 right here, so that'll be an asymptote. So we'll just put in an asymptote right there. So there's an asymptote for cosec. Our first asymptote, right along there. Where else do we have an asymptote? Well, sine of pi is 0, so there's an asymptote vertically along here. Right through pi, right there. Let me just write the pi there again. Okay, can we see the 2 pi here? There we go, 2 pi. All right, we can read that easier now. So, we've got the curve, we've got asymptote. Where else is cosec going to have an asymptote? In other words, where is sine equal to 0? Well, again, at 2 pi, right at the end. So let's put another vertical line there, an asymptote. Right there. Okay, I've got to write that 2 pi again. There we go. So we have these asymptotes. So we know now with cosec, it's not going to be able to cut through that line. So how do we draw it? Well, by the way, at sine pi on 2 is 1. Cosec pi on 2 is also going to be 1. Why? Because if sine equals 1, the reciprocal of 1 is simply 1. So that means right there we have part of the curve. And we know that cosec is, it's got a U kind of format. It looks like this. So we can put it right over there. And it goes up and out wide, but it never touches the 2 asymptotes right over here. It gets closer and closer, but never actually crosses or touches them. It just gets nearer. So there's one of the cosec curves. Now this is not a full period. The full period will have to go all the way to 2 pi. Where's the next one going to go? Well, we know that at 3 pi on 2, if we put in sine 3 pi on 2, or sine 270 if you're using degrees, that's going to give you a value of -1. So at this point right here, we could reciprocate, flip -1, and that's also going to equal, again, -1. So cosec of 3 pi on 2 is also -1. And there is its boundaries right in there, so it's going to be tucked away in there. It's going to have that U shape again, so it's going to look like this. There it is, tucked between the 2 asymptotes right over there. And again, its period is 2 pi. It repeats itself. So it starts here, then goes here, and then it continues back up here and down there, and it continues over and over again forever, for infinity. So there you have it, the curve of y equals sine x in conjunction with y equals cosec x.